Temperature is one of the most fundamental things we experience. We measure to decide what to wear, to know whether we are having a fever, and even to measure the baking of a cake. When you hear the word thermometer, you probably picture something like the classic glass tube with a silver line of mercury, or maybe it's the modern digital version with a beeper and an LCD screen. For everyday life, these tools are fantastic. The measurement is straightforward. You put the thermometer in contact with an object, wait a moment, and it tells you the temperature. But things get tricky when the objects get smaller and smaller. Imagine trying to take the temperature of a single microscopic transistor inside your computer. Or say, we want to measure the temperature of the inside of a living tissue, like a cancer tumor. Suddenly, ordinary thermometers no longer work. They are far too big for something so small. Also, simply bringing them into contact with it can change its local temperature. The measurement itself can interfere with the experiment. So, how do you take the temperature of something so tiny? You build a thermometer that is just as tiny. We've recently developed an ultra-thin thermometer made from a material called tungsten disulfide, and when I say it is thin, that is not an exaggeration. It's exactly 3 atoms thick. Because it is held together by weak van der Waals forces, it does not form complicated chemical bonds with the surface it sits on, so it can simply be picked up and placed wherever needed, on almost any surface. But if it doesn't have a screen or a gauge, how do you read it? We use light. Once the material is in place, we shine a laser onto it. The material absorbs that light and emits its own light back via a process called photoluminescence. By reading the characteristics of the light it shines back, we can read the temperature of whatever it's sitting on. So, how does a 3-atom sticker stack up against the bulky devices we're used to? To answer that, we look at 2 things: sensitivity and resolution. Sensitivity tells us how strongly the thermometer responds when the temperature changes. Higher sensitivity is better. Our 3-atom thick thermometer is around 100 times more sensitive than a standard mercury thermometer. Its sensitivity is on the same level as modern bulky digital thermometers, despite being vastly smaller. Then there is resolution, which tells us the smallest temperature change the device can reliably detect. The smaller, the better. Even though our thermometer is only 3 atoms thick, its resolution is comparable to that of standard bulky laboratory thermistors. When you look at the landscape of modern nanoscale thermometers, this 3-atom sheet sits comfortably in the top few. It offers ultra-high sensitivity without sacrificing resolution and without disturbing the microscopic worlds it measures.